Hello, I'm Arto Santala from Solita, and I'm going to do a presentation or actually demo session on some database transactions in Spring Boot. I recently did a video on how transactions work and how you can survive them, and that was just slides, it was theory based, but I wanted to show something concrete as well, some of the kind of transaction behavior and issues. And I have a very simple Spring Boot applications here that I'm going to go through to show you something. So what I have here is, well, I have Spring Boot initializer created template. It's a Java 11 level template. And I have included REST and JDBC and H2 database dependencies here, as well as developer dependencies. And I haven't done much here, but I have schema, and schema is going to create a few tables that I showed in the previous session, and I'm going to inject one seed of data. I have one product with ID1, ID1, so let's call this carrot. So I have one carrot in the database inventory, and then I have another table for the orders, waiting for the orders to come. And I have an endpoint with some very stupid REST APIs here. And I'm going to go through some details on how things work. Mainly because people not so often do these things, so people assume a lot. And every now and then it might be refreshing to actually try very simple possible example that you can get away with. Okay, let's get started. So one of the endpoints is a list contents operation. And it's mainly because I'm using H2 and I don't have a very fancy database client handily available, so this is the simplest way to check the database state. So I have in-memory database, and every time I run this again, there's 0 orders and there's one product with one quantity of 1 in the database. So let's play with this a little bit. First thing I'm going to show you here is, can I make this any larger? Nope. We view presentation mode. Yep. Let's try this one. Yeah. So first thing I'm going to show you here is testing the rollback. So I have a Spring REST controller, a very stupid modeling. Don't pay any attention to that. That's just but ugly. But what I have here is a simple to test in browser function that I can call. I have deliberately left the transactional annotation away from the method. It's also not on the class level, and there is no magic happening elsewhere. So what I do here is the example from my theory material that I showed earlier. You can go back there if you like. And see the theory material if you haven't seen it before. But the example was that we do 2 operations. So we do one update. We are going to take one item away from this storage. And then we are going to create order line out of that. And then say, okay, all good. And this time I don't have any transaction here. So let's see what's going to happen. As soon as I remember how to exit the presentation mode. Okay, so we go back here, and here I have the test rollback. I'm going to run it now once. Okay, response okay, all good. And when I refresh the database state, this is the remember the transaction is all or nothing, so this is the all example. So I got both operations to succeed. Product inventory is now to 0, so carrot is removed. And it's now in the orders, so orders have that carrot and there's 1. Okay. Now if I run it again, it will fail deliberately. So I have hard-coded the primary key here, so the second time I run this, first line will succeed, second line will fail. And it will fail with an exception that causes automated rollback. Duplicate key exception happens. And I'm assuming that I'm atomic. So if I'm atomic, it shouldn't have updated anything, so this should have remained the same. I'm assuming that storage is not changed. However, because I didn't have the transactions, I didn't have any protection. There's no atomicity. So then the quantity went to -1. So I just managed kind of a non-atomic operation that partially succeeded. I updated the storage, but there was no new order. So problem, somebody is probably figuring out that I'm a fraud because I just, something has disappeared from the inventory, but it's not sold. So where did it go? Sounds bad. Let's fix that. Okay. Let's make the function transactional. And I have the Spring Boot developer tools activated, so I'm going to rebuild and it's going to restart and it's going to grab that annotation. It's also going to reset the database back to the original state. Let's see how it does it. No. This is in-memory database, so every time I reboot, database resets to 0, which makes this fun demo platform. Yeah. So refresh just to see that it's reset. Yeah, it's good. Rollback. So I run it once, all good. Yeah. And at this point, we have moved the carrot from inventory to orders. Then I run it again. It should fail. And now you can see that quantity did not change. So we did not break the break the data. So we did not create new order line. Therefore, we did not deduct the number of products in the inventory. So this is the atomic part of database transactions. And by the way, I've seen people who are putting these on class level or slapping them blindly everywhere, and they might still not do anything. So whether this hint is run by something depends on your configurations, and that's why I picked up very simple project with none of the extra stuff. But depending on what dependencies you put and how you configure your stuff, this might work or not work. So that's why I'm testing it here, and I can prove that it works at least now. Also, do note that there is more parameters like isolation that you can define. You can define read-only for some optimization goodness. So there's some stuff that databases will treat these mildly differently, but there's some stuff that you can at least define. So you can tailor this a little bit. We also have the propagation, and there you can see propagation levels. It's a very deep topic. So definitely not topic for today. Fun topic. But the propagation accepts different values. These might be familiar if you have coded with EJB, and are definitely familiar if you have done this level stuff with Spring Data. But default is that we are supporting transactions, and then we are, well, let's check, was that the default? I think. Yeah, sorry, required, of course. So required means that we always want to have a transaction. If it's not started, we will start it here. Always require new, support existing one. If it exists, not support. If it exists, never have a transaction here. Nested, ooh, that's a topic for lengthy talk. And mandatory, you need to have a transaction coming in here. So we can fine tune these quite a lot, but as I said, let's not go there on this demo. But I just demonstrated atomicity, so let's go into isolation also a little bit. So I have something here called slow transaction, and slow transaction is going to update a product, and it's going to set quantity to some amount, and then we are going to wait until we run the next line and exit. So there's 30 seconds wait, and this is simulated delay, or this gives me enough time to simulate the multi-threaded access mainly. It would happen if we have a lot of users, but even if I have one user, within 30 seconds I can press 2 buttons, hopefully. Okay. To make this more fun, I'm going to change the isolation level. Now, don't do this, because this is not recommended, but this is for the demo. So I'm going to drop the default level. Isolation default is, well, isolation default but isolation default is typically read committed. I haven't yet seen case where it would not be, although it's not kind of defined. So it comes from the JDBC driver default, if I remember correctly. Might have it wrong. But anyway, I'm deliberately defining read uncommitted, meaning read dirty data, read data that's not yet committed or rolled back, so it's in the limbo state. Okay? So that's not really good setting, but that's why I'm setting it, so you can see how it affects things. So that okay. I think I have everything set here. Now we need to reboot, so I'm doing a rebuild. And that was the slow transaction. Yep. So I'm going to, well, let's first check what is our initial state. We rebooted, so we should again have 0 orders, 1 caret in storage. And now I'm going to do this very slow simulated transaction. So one thread is working there, and in another thread I'm going to dive in here. And here is the problem that I just caused. So that transaction is still going on, but it updated the quantity, and I can see it from another thread. So to me it seems like inventory is empty. However, it might be that that transaction ends with a rollback or commit. So it might end up cancelling, or it might end up confirming everything. 0 or everything, nothing or all. So that's the problem. It's not consistent. Another side effect is that I had a caret, but if I take the whole kind of state of database, where did the caret go? It's not in the inventory, it's not in the orders anymore. So that's a problem. And if I rolled back the transaction, this would also be kind of a phantom. It would be a ghost. So I saw something that's not real. So that's not very, very nice. And I think if you had to code with this assumption, it would not be very easy. So that's why the assumption is that there is isolation, there's locking going on. There's different kinds of locks. There's lock groups, there's write locks, there's read locks. So as I mentioned, there's a whole world of details when you go and see how the databases actually do this. But and it's good to know your database very well. I'm using H2, so it's not very great database, so it's not very clever with anything. So it's doing quite rudimentary things and not supporting everything. It's also not durable at all. If I lose the power, it resets back and it loses all the data that was in the middle of something. Okay. But I reset the isolation level and I'm rebooting the application. So let's do the same demo again once it has booted up. So when I set the read committed, it means that at least typically I would have write locks. So all the rows that I'm going to change or update or change, what's going to happen is that they will be write locked for the duration of the transaction. Once the transaction ends or rolls back, the locks will be of course released. And even if there's no explicit rollback, there's typically, when the connection times out, eventually the database should, because of the durability, database should take care of ending in either rollback or commit state, in the consistent state eventually. But let's take a look at the demo. So I rebooted database, 0 orders, 1 caret in storage. Let's test slow transaction again. So I put it running. I have 30 seconds of time and it successfully updated products quantity. And now I go here to see it. So we are of course curious what happens. First thing that we see is that I wasn't blocked. So I was able to read. But second thing is that I read the initial state. So there's quantity 1. So the other transaction has updated the quantity, but only in the transaction. It's not committed yet, so that's why it's not visible here. So it's kind of in the transaction log at this point. And once the transaction has ended, like now, when I refresh, now I see the ending result. So now we have quantity 0 and here. So both examples that I showed you ended in consistent state. So we had the atomicity, we had the isolation. When we are working with sane defaults and we are understanding what they do, we want to end and we end in a consistent state. But if you are not aware of how these things work, and if you're assuming too much, you might quite easily kind of drop off the cliff and do an error that is you will detect it very late, and it will be very costly. Architectural level change will be needed. So that's why I'm doing these videos, just to make sure watching these doesn't take too much time. And if you after this invest a few hours and research a bit deeper, then you can be the better wizard and ask me some very difficult questions, and perhaps even find some errors here in my example. It's quite probable that I have made a typo or two errors here in my speech, so please let me know if I did anything that's not true, because this is very complex world. But the area where I'm trying to stay is relatively simple, and you can really learn it and understand it within few hours of time. It's not black magic. Okay. So let's end the demo time with one final fun thing. So this is a phantom read, and I'm going to demonstrate a problem. But to be honest, this is not typically a problem for you, because instinctively people understand that this is not an assumption to make. But I'm still going to show it, just so you understand the concept. So phantom read means that you are able to read something that's not in the middle of transaction, but it's also not, so it's committed data, but it's still something that doesn't exist. So it might be that you are asking, show me all the products, and then you run the same again, and if you think that database state hasn't changed here, of course it might have changed. So between this time, somebody might have updated the products, and there is this is my trick again, to sleep 30 seconds to make that probability very high, so I have time to do some operation here. And yeah, let's run this with defaults without any fancy stuff going on. So I don't remember if I reboot this module, but let's reboot it. Yeah. Okay. So getting a new version. I think I might already have rebooted it, but I will hard reboot it once. Okay, so what I'm going to do is run these and show you what happens. I think you can probably guess it already by this point. As I said, this is very instinctive. So if I do something and then I wait for a long time, of course the world has changed here, because otherwise there should be very heavy locking. So if they didn't change, what would have happened? You would need to basically lock the whole table to avoid all the problems. So you would have to have either own copy in own dimension of the product table that's unchanged during the transaction, so you can read it multiple times and nothing changes except by your own actions. Or you would need to lock it. So you just enforce locking, but table level locks are really great way to shoot yourself in the foot, so to say. So don't do them. So I'm going to trigger the phantom read now, and then I have a transaction. So phantom read all these once, and then I'm going to do transaction operation. I'm altering the state of the database, and I'm reading it here. So state is as it should be. So I did a transaction, and while the other phantom read example was running, I set the quantity to 0 and added new item to my order items. And then when I go back here, we can interpret this a little bit. So we have orders before, empty. But then I ran it again in same transaction, and now it's not empty. So that's a phantom read. I also see products before, but then after it has changed. So as you can see, I cannot. It's not repeatable read, and also the amount of rows has changed. So there's two issues that I'm demonstrating here. And if we stop for a moment, as I said, these are probably not problems for you as long as you realize this is how it works. So I've sometimes seen that programmers think that this is kind of isolated world, and as you're testing single-threaded, that's how it looks like. So if I'm only running this in one thread, I run it, unless I change the state, it's still the same. So it seems like this code might work. But the second somebody runs a thread at the same time, then we have problem. So you can block that, of course. I'm not going to do that demo because I find that too disgusting to do. You can do serializable or repeatable read for a bit less, but you need to deal with the read locks and table level locks, or at least large group locks. So the probabilities of deadlocking or huge performance bottlenecks where one thread is executing and all the others are waiting, it increases a lot. So really you shouldn't be doing this. Instead, as I said, adjust your assumptions. So assume that you cannot assume much. Assume that when you do two reads, state might have been changed by other threads, and then you'll be fine. So there's things like optimistic locking. You can have some timestamps on when the row was updated. You can have a just cached copy, and you can manipulate it to all your heart's desire. And then before you are pushing it back to database, at that point you can check the timestamps again. So there's many ways to deal with this other than heavy locking. But as I said, most important thing here is to understand a bit on how the mechanism is working farther than just slapping transactional everywhere. And as a benefit from that, you will get less headaches and possibly sometimes even more performance when you understand where you can adjust things and where you can loosen your expectations a little bit. Yeah. So I hope this was fun for you. The source code again is in GitHub. It's not in Solita GitHub. It's in my own personal one. So if you watched the earlier videos of the series, you know where that is and you can look it up. You can take my code examples and educate others with them, or you can even extend them and put all the problems and their showings here. So if I made a heavier, longer demo, it would probably include some stress test demos as well. Gatling. So turn off the transactions, run Gatling for a bit and see how consistent your database is. That's always fun. And we might also have some more sophisticated tools to kind of diagnose and monitor these things, which come along with the relational databases most often. As always, I hope this was fun for you. I hope this was interesting. If you liked what you see here, leave some feedback. If you hated it, leave some feedback. If you saw something where I kind of made a boo-boo, so if I messed up something and I said something wrong, let me know, because that helps me grow as well. So I'm quite confident on the kind of big lines here. It's based on experience and not assumption. I have been trying these and reading a lot, but this is very complicated area. There's endless supply of little details, especially when you go to how the databases really deal with these assumptions. Then you start to see really complicated stuff and really interesting things. I have more than once been caught unprepared when I assumed something based on another database, and then it works differently in another one. Okay, thank you for watching this. I hope you return for more quality content. Bye bye.